So what we have here is a linear programming problem. So what I'd like you to do first is just to pause the video and read the problem before we go on. And now that you're back and have read all the particulars, let's try to translate all of these words into equations and inequalities. So what we have are two types of paper clips. So I'm going to say that X is the number of batches of the regular. And I'm going to say Y is the number of batches of the extra large. So that's what we're looking to figure out how much to produce. Okay. So what we have are the two processes that are here. And what makes this linear programming pretty much is that we're trying to find a maximum something. So either way we go, do we get the inequalities first? Do we get the objective function first? Since it's the last thing we read, what makes this linear programming is how many batches of each type of paperclip should be sold in order to maximize profit. So I want to maximize. Now, we always call these things Z. I'm going to call it P because it actually means something to us. And what we are told in this passage right here, each batch of standard gives us $4, and each batch of extra large gets us $5. Okay? And actually what I realized here is that this isn't necessarily sold, this is produced. It's kind of a minor point because we're assuming that we sell whatever we produce. So this is what our objective function is going to be. So we're not going to graph that. The constraints come from things that are available. So as far as constraints go, we are told that each batch of regular paper clips requires 15 minutes for cutting and 30 for shaping, and then each batch of extra large clips requires 20 for cutting and 20 for shaping. Okay, so what we're also told right here, manager has determined that there are 4 hours available for cutting and 6 for shaping. So here's what we have. So this is per batch. So if we have the regular and we have the extra large, organizing into a table, I think is a beautiful way to do this. So we know that each batch of regular clips requires 15 minutes of cutting and 30 minutes for shaping. And we're told that this is 20 and 20. And what we are told is that we have 4 hours available for cutting, so that's 240 minutes. And we have 360 minutes available for shaping. So my constraints reading this way tell me that 15x plus 20y is less than or equal to, 240. And 30x plus 20y is less than or equal to 360. So here we're not assuming that we use everything that's available, but knowing that it is available, whatever I produce has to be less than or equal to. Okay. Now, another natural constraint that occurs is that, I can't produce negative quantities. So I'm going to also say that x is greater than or equal to 0 and y is greater than or equal to 0. So great, there's my feasible region. This is going to tell me where all my possible solutions come from. So what I need to do is graph the feasible region. And notice that this is the typical setup for a maximization problem. All of my inequalities are pointing in the less than or equal to direction, which means I'm going to be underneath stuff. And x and y are both greater than or equal to 0, which means I'm bound to the first quadrant. So that in itself makes sense. So what I'm going to do when I graph, whoa, that's pretty bad. That's not a straight line. So here comes a straight vertical line. Wow, that's pretty bad. All right. And then straight up horizontal line. There we go. Okay. So 15x plus 20y equals 240. I'm going to do this over here. I'm going to try not to use Desmos for this one because doing these by hand isn't too bad. So if x is 0, that means I have 20y equals 240, which means y is 12. And if y is 0, that means I have 15x equals 240, and that means x equals 16. So I have 0, 12, which I'm going to put here. And I have 16, 0, which I'm going to put here. Now I'm going to change colors for the other graph. So I have 30x plus 20y equals 360. And okay, if y is 0, I have 30x equals 360, which means x equals 12. And if x equals 0, I have 20y equals 360, which means y equals 18. So what that means is the other graph goes above the 0, 12, so that's 0, comma 18. And I have 12, comma 0, so that's about right there. So if I connect my dots, this is the only part of the line that I really care about. I'm actually going to come back here and make the other one. Great. Now what we know is that my feasible region is going to be this region, below all the lines, but in the first quadrant. So checking with the less than or equal to business, that's what we're going to get into there. So what I need to do, though, is find that point of intersection, because that's a corner point. We know that the maximum can occur at a corner point. We already have that 0, 12, and 12, 0 are corner points. So what's this other one? Well, we could solve the system of equations by hand, or we could go to Desmos, whatever. I am going to take advantage, though, of having the same coefficient of y. And I'm going to do something a little unorthodox here. I could multiply one of the equations by -1 and add. That's the same as subtracting one equation from the other. So I'm going to subtract this minus this. So 30 minus 15 is 15x. 20s go away. 360 minus 240 is 120. So it looks like x is equal to 8. And if I plug x equals 8 into either one of the equations, it looks like I'm going to get y equals 6. So that's another point of intersection. So what I need to do is check each of those corner points and plug them into the objective function, which was 4x plus 5y. Oh, that was p, though. P equals 4x plus 5y. So for the point 0, 12, and then we have the point 12, 0, and then we have the point 8, 6. So something interesting is going to happen here. So 0, 12. Well, if I plug in 0 for x and 12 for y, I get 4 times 0, which is 0, 5 times 12, which is 60. That looks like 60. If I plug in 12, 0, I get 4 times 12, which is 48, plus 0. That gives me 48. And if I plug in 8, 6, this is the one that takes a little bit more work. But let's see if we get reward out of it. So 4 times 8 plus 5 times 6 looks like it's 62. And look at that. There's our max. So in order to maximize their profit, you're going to create 8 batches of regular and 6 batches of extra large. So hopefully this problem helps you to understand linear programming a little bit better. I thank you for watching. There will be more coming because we have a lot of things to discuss. So I hope you come back and watch more.